Hello, this is one way you can calculate the percent by mass of carbon in sodium bicarbonate. The theoretical percent. What you need to do is the following. You have only one atom of carbon, so that will be the mass of carbon over 1 time the atomic mass of sodium bicarbonate. And that will be multiplied by 100. That will be the way you calculate the theoretical percent of carbon in sodium bicarbonate. What will be the mass of carbon here in the formula? Well, you need to check the periodic table. On the periodic table, the mass of the atomic mass of carbon, there is a formula that relates the number of mole with the mass and the molar mass of carbon. So for finding the mass, you need to multiply number of mole times the atomic mass. You have one atom of carbon, so you have one mole only. And the atomic mass of carbon, I just memorized the value, is 12.00. So that will be the one that you place here on the top. 12.00 gram, and that will be your mass of carbon. Then the next thing will be finding the molar mass of sodium carbonate. How can you find the molar mass of sodium carbonate? Well, you need to do the following. Molar mass of sodium bicarbonate will be equal to 1 time, because you have one atom of sodium, times the atomic mass of sodium, plus 1 time the atomic mass of hydrogen, plus 1 time the atomic mass of carbon, plus 3 times the atomic mass of oxygen. That will be the way you will do the calculation. So if I go to the periodic table, I got, let me check my periodic table. The atomic mass of sodium is 22.98, 22.98. The atomic mass of hydrogen will be 1.00. The atomic mass of carbon, we already used that, 12.00. So that will be 12.00. And the atomic mass of oxygen will be 3 times 15.99. So solving for that, I will get the following value. Actually, let me do the calculation on the side. Okay, and atomic mass of that will be, based on my calculation here, 84.00 gram per mole. I'm going to use only 2 decimal place. So that will be the value that I will place here, 84.00 gram over mole. Mole and mole, gram and gram cancel out. And you need to divide 12 over 84. So using my calculator again, I had to do the following. 12 divide 84 and multiply by 100. It gave me 14.28% of carbon in sodium bicarbonate. This is the theoretical value, and you have to compare this one with the practical value. How? Well, you can find the percent of error like this way, percent error, and that will be your actual value, that I don't know what it is, your actual value. Let's put X is the one that you go doing the experiment, minus, notice that I put on module, so it means the number has to be positive at the end, minus the theoretical value that I just calculate over the 14.28, which is the theoretical value times 100. And that can give you the percent error, how far you were from the theoretical value. And that's the way I will do the calculation for finding percent error, or if you want to find also the actual yield, you can also, let me see if I can move my page to the left. Yes, you can, if you want to find the actual yield, you can do the following. Percent yield, which is another calculation, will be equal to the actual yield, the one that you go in your experiment, over the theoretical one times 100. The actual yield, or the percent that you go in your experiment, I don't know, I'm going to call X, and then you divide over the theoretical percent, which is the one that you just found using the atomic mass, times 100. Let's suppose that yours, again, this is percent yield, that the experimental one you go is equal to the theoretical one. This is just a supposition, because I'm not sure if you go this. So let's suppose you go exactly the same. Well, the percent yield, or like the calculation, will be 100%. And that will be some of the calculation you need to do with your experiment with the lab you did. Thank you for watching. Bye.